In this lesson, we're going to talk about area of circles and sector area. So let's remember and refresh ourselves what an area of a circle is. We know that it's all the shaded area of a circle. So our formula is A equals pi r squared, with A being the area and r being the radius, and of course we square it. So let's try this one just as a refresher. So remember, when we always do area, our units are going to be squared because we're talking about two dimensionals, because we use this square in our formula. Now, to find the shaded area of the sector, we're going to use our prior knowledge with our information that we learned about with arc lengths and central angles, and we're going to find what we have. So notice that we have 60 degrees as our central angle. So if we want to know the arc measure, we would know it's 60 degrees, but we want to know the length. Okay, so we're going to use that same ratio and find out what percentage of that is our shaded part. We want to know what percentage that is of the whole circle. So if we think about taking 60 divided by 360, we know that that is 1/6 of the circle. So this is 1/6 of the circle. So if we think about finding area, if we weren't finding any shaded, we would find our area with our radius of 5, which we've already done. So we already know that it's 78.54 units squared. And in this case, we're going to divide it or multiply it by 1/6, which is the same thing as dividing by 6. So we end up with 13.09 units squared of the shaded area. So again, there's a relationship and a ratio, a proportion that we can set up to help us with this. So we take our central angle, divide by our total degrees in our circle, and then we multiply it by the area formula, needing our radius. So I want you to try these and see how you do, just with this simple knowledge. So take a look and see how you did. All right, we're going to go a little bit more in depth and try a couple of more. So point C is the center of the circle above, or to the side here. What fraction of the area of the circle is the area of the shaded region? All they're asking is the fraction of the circle. So if we know that this is 100 degrees, and that means we want to talk about just this piece, how much of the circle is it taking up? That is just using your ratio of your central angle measure divided by your total degrees of a circle, and you would end up with 5/18. We're going to find the area of the sector shown. Again, these are shaded areas. We're given the central, and we're also given the radius. Here are your answers. Next one, we're given some circumference, and we've got to find the area of the shaded sector. So we're given circumference already. So we already know what circumference is, and again, circumference is all the way around. And we know that that was 100 pi. We're going to find the shaded area. What do we need to find? Well, I hope you say we need to find the radius because it's not marked. So first you need to find the radius, and then once you have that, you can use it to plug into your formula and find the area of the shaded sector. So give it a try and see how you do. This one you should have gotten 981 and 75/100 units squared. And again, that is rounded. To a little bit more complex problem. And this particular one, we have circle O. Its diameter is AB. There's a chord BC and a radius OC. Okay, so immediately we know that this little segment from here to here, here to here, and here to here are all congruent. And it tells us that the measure of arc BC is 108. Some students wrote these formulas to find the area of the sector COB. So take a look at Amy, Beth, Carl, and Dex and see which ones would actually help us find the area of sector COB. So when we look at their different formulas, the first one with Amy, her BC is not the radius, and that's what we're looking for. I went ahead and found our 108 over 360 and know that it was 3/10. So the first part is right on all of them. So we're good with that. But she just has a chord. That is not what we need. We need the radius. So she is out. Beth's OC is a radius. We were given that. So hers will work. Carl, his half of AB is the diameter, and half of that would be the radius, so his would work. Dex, however, just has AB, which is the diameter, so Dex will not work. So the only ones that will work will be Beth and Carl, so that is our option 2. We have one final problem. This one you will actually draw out and leave in terms of pi. We are trying to determine and state the area of a sector that intercepts at a 40-degree arc of a circle with a radius of 4.5. So sketch it out and see how you do. All right, so once you figured out what the picture would look like, then you could find the central angle because you were given the arc degree, so you could find the degree of the central angle. That allowed you then to find the fraction of the circle that was shaded, which was 1/9, and then we plugged into our formula. Now we're leaving this in terms of pi, so I did not calculate out the pi. So I went ahead and just did the 4.5 squared, and then multiply it by 1/9. I get 20.25 divided by 9, and then that simplifies down to 2.25 pi units squared.